Hello, guys. This is my first attempt to broadcast something using YouTube Live and Google Hangouts. Um, I'll Today I'll be going through creating a React app. One of my clients would like me to create a React app for them. So this is an attempt. I have never created a React app. This will be my first React app, and I'll be using. I'll be doing this on a Ubuntu version Ubuntu. Basically, there's nothing on it other than Google Chrome. I deleted the rest of it. It's basically a version Ubuntu 16.04. So let's get started. So I'll first go and search for how to get started with how to get started creating a React app. Let me see. So let me see. Let's type React and see. I'll search for React. It takes me to the Facebook page. I'm going to open this link to see how to get started. I've gone through the basics of React. By the way, I just went through for like an hour. I reviewed what React is about, but I haven't created anything. So this is where React takes me. They say it's declarative, it's component-based, and learn once and write anywhere. This is all good. They show how a simple component how to build a simple component. So they show how to do it using JSX. Basically, this is how you render a React component, I guess. I will go through this real quick because I want to do a real tutorial. So anyway, so they have a render, looks like the React component itself has a render method. That's what we need to use to render a component or some HTML to the DOM, I guess. I will go through the next one. I think they have a few other methods. So I mean, in this component, they again extend React component. They have a constructor. In the constructor, they're setting state. And looks like they use a lot of ES6 syntax. So they are setting state, and looks like when this component did mount, looks like it gets called. It is getting called whenever the component is added to the DOM, I'm guessing. So they're setting an interval. Looks like every 1 second they call the tick. This tick method, and the tick method is turning around and setting the state. And basically, it's updating the seconds elapsed. And looks like the component will unmount method. I think it gets called when this component is removed from the DOM. So it is clearing the interval, which is pretty straightforward. And the render method again, it's just it's returning the div with the latest update. Oh, okay. So this one, I think this field is bound. So this binding, I'm guessing this is the way they bind it. So they're binding the seconds elapsed. So I think here they're showing it. So the seconds elapsed gets updated. React itself is doing the diff, I guess. So anyway, that's one thing. I'll just quickly go through this because I want to go through a tutorial from starting to end instead of using something simple like this. I might have to install an editor. We'll see. So using props and state, Okay, so this is showing how to use some properties and state, I guess. Looks like this is a to-do app. So let's see what happens when I add this. Okay, so basically, uh, so this is more of an app, which I'm sure it's more complicated. So it looks like they have a, we'll start from the bottom. So they created a to-do list React component, and the to-do list React component um, is calling the render method. The render method is turning around and creating the element. So as simple as that. Okay. So this is where looks like this is the method that's get called to um, put this element onto the DOM or the word, yeah. So they have the concept of virtual DOM. So anyway, we'll get to it when we go through some more examples, I guess. Here looks like it's just extending a React component, and it has a UL tag, and then this one, oh, okay, this one is showing a list of items. So as the user enters it, as the items are added, I'm guessing that it gets added to this item array, and then they're displaying it. So let's see how to-do list is used. So handle submit event. So looks like so looks like here as the input changes, so handle change event is getting triggered, and then that is setting set state text. Okay, so basically they are setting the text state. So to the value the user entered here, let's say I entered test2, and test2 is basically getting set in the state. And I don't know if this creates a new item in this array. I don't see it call a push, but anyway, so we'll see. So as soon as the user changes state, the okay, set state. Okay, so I'm guessing this adds a new value, but anyway, we'll see how this works. So the user yeah, the user enters something and hits enter, so it detects the change event, and then it's setting the new state. Uh, the button items not okay, so this is incrementing the number of items. Oh, add number 3. Okay, so this is the button text itself is being changed. So as we add new items to the array, so this is bumping it up. So I'm sure it is initial. Okay. So that said, okay, handle submit. Where is handle submit? Okay, form. Okay, so looks like when I this form submit. I don't know where this form submit is, how this form submit is getting called. Let's see. So I wonder, so this button click is actually doing the submit, I'm guessing. So if that is the case, so it's preventing the default. It goes and it's setting the text, and then it's setting the state. Okay. We'll get into the details when we do a real example. So a component using external plugins. React is flexible and provides hooks that allow you to interface with other libraries and frameworks. This example uses Remarkable, an external markdown library, to convert the text area's value in real time. Okay. So let's see. Let me type some markdown here. I'll use the typical bold and see if it does anything. Yep, it did convert it to bold. So the user, it takes the user input, and if it is a markdown tag, then it's converting it to the respective value using the Remarkable plugin. So let's see how they use the Remarkable plugin here. So they just created a component. Again, it extends React component, and then they're calling the super method, and then they're calling the handle change event. Okay, so they're binding this element's handle change event. Okay, so this syntax, I'm new to this kind of syntax. I don't know what they're doing here, but anyway. So set state value. So looks like they're setting the state. Get raw markup. Okay, so this is where they're using the Remarkable external library. And this one is returning the marked up HTML. And what they're rendering is a simple div. Inside of simple div, they have a input header, and they have text area where the user can enter multi-line text. And they have a output header and the contents of the output. I mean, how the conversion from Markdown to HTML. I don't know why this. I think dangerously set inner HTML. I don't know why they are saying something like this, but anyway. Cool. So at a high level, looks like so that's a simple tutorial, I guess. So let me dive into the get started and see what more they have in get started. Okay. In get started, they have something like the easiest way to get started with React is to use this hello world example code on CodePen. Okay. So let's open CodePen. Again, I'm running this on a Ubuntu inside a virtual box. So if you see the screen not being really smooth, it's because of VirtualBox and the combination of VirtualBox and Ubuntu running inside of it. I just wanted to start from scratch and not have any of the dependencies on my laptop interfere. So it's taking a little more time to put these screens next to each other. Okay, so what are they saying here? The easiest way to get started with React is to use this hello world example code in CodePen. So I opened CodePen. You don't need to install anything. You can just open it in another tab and follow along as we go through examples. If you rather use a local development environment, check out the installation page. Yeah, right now, because I just started, I don't want to install anything. I'll just go through whatever they have here and then learn it the way they want me to learn it, I guess. So the smallest React example looks like this. Okay, so that's exactly what I have here. It renders a header saying hello world. Okay, so I see the header tag and they're rendering hello world, which is pretty easy to understand. And then document.getElement by ID root. I don't know what. So I wonder if in the HTML there is something called. So basically the render function is taking two arguments. The first argument is a header tag, and the second one looks like it is the parent element where this hello world should be attached to, I guess. So let me go and see the HTML and see if the HTML has a root tag. Okay. Why would it not let me go to the HTML? Oh, there it is. I think it's Ubuntu. I'm running this on Ubuntu in VirtualBox. So when I double click, it took some time to open it up. Yep. As you can see, the HTML has a div with ID root. That's exactly what they did here. I can resize it like this also to see all three sections in CodePen. Okay. So there is no CSS. There is just HTML and JS. In the JS, I'll reduce the size of the CSS section so you can see the HTML and JS properly. So in the, yeah, as you can see, it is pretty simple there. The first argument again is hello world, and the second one is they are sending the root element itself, which is this div, and looks like this hello world will be somewhere here. Yeah, the div's content is basically being managed by React. That's what this is doing, I think. Cool. That said, what else? The next few sections will gradually introduce you to React. We will examine the building blocks of React apps, elements and components. Once you master them, you can create complex app from small reusable pieces. Okay, good. A note on JavaScript. React is a JavaScript library, and so it assumes you have a basic understanding of JavaScript language. Cool. If you don't feel very confident, we recommend refreshing your knowledge so you can follow along more easily. So it looks like this is a good link. It's pointing to a Mozilla MDN, Mozilla Developer Network reference. So this will be pretty good, but I won't go through JavaScript. I'll keep the focus on React. So we also use some ES6 syntax in the examples. We try to use it sparingly because it's still relatively new. And ES6, I think most modern browsers support it. So there is no reason not to use ES6. Anyway, for my project, I'll use ES6 heavily. So, but we encourage you to get familiar with arrow functions. Okay, we'll use arrow functions, classes, template literals, letcon statements. You can use Babel REPL to check what ES6 code compiles to. I'll skip that also. Okay, so this is the first page of the quick start. So let me tinker with this and see what happens. So let's say instead of hello world, I want to say hello world. I'll add this sentence and then see if I can run this. As you can see, Ubuntu running inside VirtualBox takes some time to refresh, I guess. Okay, so how do I run this? Oh, there it is. Okay, it refreshes automatically. So let me see. Let me add something like some additional tags and see. Does it CodePen automatically render this? So do I need to, yeah, so it renders automatically. So I think it's looking for changes in the code and it's rendering on the fly, which is good. So if I want to tinker with this some more, I can actually tinker with it. So instead of calling the ID root, so let me say my ID is actually called app shell or something like that. And then I'll change this to app shell and let me see if it'll still render. Yep, still rendering, which is good. So that's how React is rendering, I guess. So let me go to the next section. The resizing of the window here is not working properly. I think it's because, again, I'm running within Ubuntu. So let me see. Okay, this is good enough. Oh no, it made it bigger. Maybe I need to drag it from there. Yep, there it is. Okay, so let's go to the next section. So in the next section, so this one is introducing JSX. So consider this variable declaration. Const, okay, so they're declaring a variable, which is called, not a variable actually, it's a const called element, which is immutable, but I don't know what is its data type because I mean this one looks like, I don't know how assignment like this works. This funny tag syntax is neither a string nor HTML. Okay, that's what we were thinking. So it is called JSX. Okay, and it is a syntax extension to JavaScript. We recommend using it with React to describe what the UI should look like. JSX may remind you of a template language, but it comes with the full power of JavaScript. Okay. JSX produces React elements. We will explore rendering them to the DOM in the next section. Okay. Below you can find the basics of JSX necessary to get you started. Okay. Embedding expressions in JSX. You can embed any JavaScript expression in JSX by wrapping it in curly braces. Okay. Okay, so there is a link to, again, Mozilla's website. I'll talk about what JavaScript expressions are. Let me see what they're talking about. Nothing new here. Okay. So something that evaluates, I guess. So I'll skip that. So you can embed any JavaScript expression in JSX by wrapping it in curly braces. So if I want to evaluate an expression, I just wrap it in curly braces. I think one example, I think they're talking about something like this. Looks like the stuff inside of the curly braces, mainly format name user, that is an expression. So it looks like in JSX, I can have something like this, and it evaluates that expression. So that's what they're talking about. For example, okay, they give an example here: 2 plus 2, user.firstname, format user are all valid expressions. Okay, good. So function format name user. Okay, so they have a function uh, which is called inside of JSX. I mean, basically you pass it a user. Looks like the user object has a first name and a last name property, and it concatenates both of them and returns it. Now here is the user JSON object, and basically it has a first name and a last name, two properties, and then this format name, it's taking it and appending the first name to the last name with a space in between. So this is pretty simple, and then he's basically creating a const. So as they were saying earlier, JSX, I mean, it's neither a string nor a HTML. Looks like I can declare something like this. This is something new to me. So, and then when it comes time to rendering it, I think, so the first part of it is taking the JSX, I don't know, a JSX object, I'm guessing. So I don't know what the right terminology is. Let's see. Or a JSX variable. Okay. Okay. So it's taking a JSX variable as the first argument, and the second argument is the root. The second argument is again the root element. And then it takes it, basically it's evaluating this expression, and then it renders it, I guess. Okay. So try it in CodePen. So let me see. I'll go ahead and try that in CodePen. Okay, so maybe I got it wrong. Okay, let me get back to this. Copy link address. Why is it not copying it? Or is it slow? I can just open it in a new window. Okay, again. Okay. It's taking some time to repaint. Okay, that's good enough. Okay. So anyway, so I have both of these. So let's see. So again, I'll open the HTML again. Looks like mostly the CSS is empty. So I'll only show the JS and HTML. Okay. So this is the example they tried. So if I change this to something else, so as yep, so it changed hello live Paris. So I'll change this to coding, and I should see the change immediately. Yep, because it's binding. I think it's listening for changes in the first name and last name. As soon as first name or last name changes, it's evaluating the expression again, and it's putting it here. Okay, so I'll go to the next part of it. I'm trying to clean up my system to see if I can make this any faster. Anyway, so that's where it is. So we finished this part. So let me try to see what's the next part. I think in the next section they talk about we split JSX over multiple lines for readability. Okay, so I think they're splitting HTML over multiple lines for readability. Okay, so after compilation, oh yeah, those JSX expressions become regular JavaScript objects. So this means that you can use JSX inside of if statements and for loops and assign it to variables. Okay, after compilation, so this means that you can use JSX inside of if statements and for loops. So let's look at the next one. So this function, so basically it's taking the user and formatting the user and returning it. So if if the user is if the user turns out to be falsy, then basically it's just saying, hey, I don't know who the user is. It returns a tag like this. And so it looks like this is a JSX syntax. So the next part of it is specifying attributes with JSX. So you may use, so looks like you can use quotes to specify string literals as attributes. So you may use quotes to specify string literals. Again, this is another JSX variable, I guess. They're defining it this way. Um, they have a string literal div. Okay, that's okay. Nothing out of our understanding. So you may also use curly braces to embed a JavaScript expression in an attribute. Oh, okay. So looks like this gets evaluated if we do something like this. So if I want to set the image at runtime, I do something like this. So don't put quotes around curly braces, okay? So they don't want you to put quotes around curly braces when embedding a JavaScript expression in an attribute. Otherwise, JSX will treat the attribute as a string literal rather than an expression. Okay. So if I put it in quotes, then it'll treat it as a string instead of an expression. Makes sense. You should either use quotes for string literals or curly braces for expressions, but not both in the same attribute. Okay. Specifying children with JSX. If a tag is empty, you may close it immediately with /greater than sign like XML. Okay. If a tag is empty, I don't know what that really means and why we would need something like this. Yeah, I don't see a big difference between something like this and something like this. But anyway, so JSX tags may contain children. Okay. Okay. So it's simple. It looks like a simple HTML. So the JSX tags may contain children. So it looks like this div has H1 and H2 as its children. There is a caveat. Since JSX is closer to JavaScript than HTML, React DOM uses camel case property naming conventions instead of HTML attributes. I forgot to change this back. Let me change this back. Okay. Specifying children with JSX. If a tag is empty, you may close it immediately with /. Okay, that's where JSX tags may contain children. Okay, they are children. JSX is closer to JavaScript than HTML. React DOM uses camel case property naming conventions instead of HTML attributes. So closer to JavaScript than HTML. React DOM uses camel case property naming conventions instead of HTML attributes. For example, class becomes class name in JSX, and tab index becomes tab index. So what else? I need to see where they are using something like this. Okay, so the tab index thing makes sense, but yeah. Anyway, we'll see some examples of this at a later time, I guess. Basically, they're saying they use camel case. So const title, okay, it is safe to embed user input in JSX. Response as potentially malicious input. This is safe, okay? By default, React DOM escapes any values embedded in JSX before rendering them, okay? You can never inject anything that's not explicitly written in your application. Everything is converted to a string before being rendered. Okay, so this is for preventing cross-site scripting attacks, so which are, I mean, I can put something like a, yeah, you can do SQL injection and then attack a website by making the user input. If you don't encode it, or if you don't escape it, lots of problems it can cause. So that, which is good. So whatever the user enters, it will take care of escaping it. So JSX represents objects. Babel compiles JSX down to React create element calls. These two examples are identical. Const element equals, let me move my desk up. Okay, just moved my setup. So JSX represents objects. Babel compiles JSX down to React create element calls. These two examples are identical. If you do a const element equals h1 class name, hello world, blah, blah, blah. So that is equal to const element create element, okay? JSX represents objects. Okay. I wonder if I can just code everything in JavaScript then, if it's going to compile like that. So so basically the h1 part of it translates to the first argument, and the class name is translating to the second one. Okay, I am back. So I had to move to another conference room. So anyway, we were looking at uh, how JSX represents objects. So looks like it translates a JSX tag. Babel translates a JSX tag like this. JSX tag like this to JavaScript like this, and I'm guessing this will in turn the create element method will in turn call the native HTML create element to create the element itself. So React create element performs a few checks to help you write bug-free code, but essentially it creates an object like this. Oh, okay. So basically it's turning it around and creating an object like this. I'm next to the airport. I think if the plane noise becomes a little louder, so I'll close the blinds here. I'll close the shutter here, so it will be less noisy. But anyway, um, so the next part of it is these objects are called React elements. Okay, so it looks like I don't know what these objects mean here, but you can think of them as descriptions of what you want to see on the screen. React reads these objects. I'm guessing this is called a React object. Okay. You can think of them as descriptions of what you want to see on the screen. React reads these objects and uses them to construct the DOM and keep it up to date. Okay, so React reads these and to construct the DOM and keeps the DOM up to date. So it looks like if the children's this property changes, I'm guessing React will track the change, will look at the property changed event or something, and then it will update the DOM accordingly. We will explore rendering React elements to the DOM in the next section. Okay. So I have a tip here. The tip says we recommend searching for a Babel syntax scheme for your editor of choice so that both ESX and JSX code is properly highlighted. Okay. So we'll have to look for a plugin. I think, let's say we use Visual Studio Code, we'll have to figure out. We haven't gotten to what editor we'll be using, but anyway, he's saying that I need to get a plugin that will allow um, syntax highlighting. Let's go to the next section. So elements are the smallest building blocks of React apps. An element describes what you want to see on the screen. Okay, so this is the looks like this kind of syntax just defines a simple element. Unlike browser DOM elements, React elements are plain objects and are cheap to create. React DOM takes care of updating the DOM to match the React elements. So React DOM takes something like this and updates the DOM. One might confuse elements with a more widely known concept of components. We will introduce components in the next section. Elements are what components are made of. And we encourage you to read this section before jumping ahead. Rendering an element into the DOM. Let's say there is a div somewhere in your HTML file. So rendering an element, okay. one might confuse elements with a more widely known concept of components. We will introduce components in the next section. Elements are what components are made of, and we encourage to read this section before jumping ahead. Okay. So they're saying an element is different from a DOM, so we shouldn't be confusing something like this with a React component itself. Rendering an element into the DOM. Let's say there is a div somewhere in your HTML file. So let's say they're saying, let's say we have a div something like this. So we call this a root DOM node because everything inside it will be managed by React DOM. Okay. So it looks like the root DOM, everything inside of it will be managed by React. Application built with just React usually have a single root node. So if you're integrating React into an existing app, you may have as many isolated root DOM nodes as you like. So we'll be building a simple React app. So we won't be integrating it with any other app. So it looks like, at least in the app that I'll be creating, there'll be only one root DOM node, and everything will be rendered inside of this node, inside of this div. So the next one is saying to render a React element into a root DOM node, pass both React DOM node.render. Oh, saying to render a React element into a root DOM node, pass both to React DOM.render. Okay, so basically this is, we talked about this a little. So the element, so we need to pass the element as the first argument and the root DOM itself, and that will take care of it. I think this hello world, we already did the hello world, so I won't go into it again. So the next part of it is updating the rendered element. So React elements are immutable. Once you create an element, you can't change its children or attributes. An element is like a single frame in a movie. It represents the UI at a certain point in time. So basically, he's saying that the element is immutable. So maybe you can change the contents of the element, or anyway. So we'll see what that exactly means. With our knowledge so far, the only way to update the UI is to create a new element and pass it to the React DOM render. Okay. Consider this ticking clock example. Okay. So there is a function called tick, and that is updating, that's creating an element. Looks like a JSX element. And it has an expression inside of it, which is a date. So this will, so we are asking it to render it to the root. Set interval tick. Okay. So this is supposed to call, the set interval is supposed to call the tick function every 1 second, as you can see from here. So it's updating it it's calling tick every 1 second, and this element is getting created every 1 second. Oh, so the tick function does both. I think it's creating a brand new element every 1 second, and then it's saying render it every 1 second. So it's, the tick method is doing two things. The tick function is doing two things. It's creating an element, and then it's saying that, hey, render this element to the root div, if I'm understanding it correctly. So let's see what happens. Oops, didn't want that. Okay. I wanted to open this in a new window. I'm going to I will resize this window once more, only if the OS can give me control. I think it's doing something. Yeah, running VirtualBox on a Mac OS, basically a MacBook, is not the best way to do these things, I think, because I'm clicking and looks like the event is getting processed after a really long time. Okay. Let's see what's happening here. Again, the HTML just has a div root, and this is the JS. Yeah, it is updating it. So updating the REMU. Yeah, so basically, the point of this, I'm guessing, is I'll have to render a new element. So I cannot update the element that's already out there in the view. So I'll have to send it a new element to be rendered, I think, every time. And it looks like React will take care of doing the diff and seeing that, hey, if there is an element already, it will go and update it. I don't know how expensive this is, but it calls React DOM's render every second from the set interval callback. Okay, understood. In practice, most React apps only call React DOM.render once. In the next sections, we'll learn how such code gets encapsulated into stateful components. We recommend that you don't skip topics because they build on each other. In practice, most React apps only call React DOM render once. In the next section, we'll learn how such code gets encapsulated into stateful components. Okay, so looks like this render only gets called once, but we'll see. We recommend that you don't skip topics because they build on each other. Okay, understood. So React only updates what's necessary. React DOM, okay. So React DOM compares the element to its children. React DOM compares the element and its children to the previous one and only applies the DOM updates necessary to bring the DOM to the desired state. Okay. You can verify by inspecting the last example with browser tools. Okay, so React is taking care of the updates like this, is what he's saying. So it's doing a diff, and because only time is the only part that's changing, so it's only it's updating the time portion of the DOM only. Even though we create an element describing the whole UI tree on every tick, Only the text node whose contents has changed gets updated by React DOM. In our experience, thinking about how the UI should look at any given moment rather than how to change it over time eliminates the whole class of blocks. Okay. So they're saying that, okay. So anyway, so this is what they're saying. So that's the reason why they make you update the whole UI. And then they will take care of doing the diff and updating only the necessary parts. So let's see what else. So components and props. Components let you split the UI into independent reusable pieces and think about each piece in isolation. Conceptually, components are like JavaScript functions. So components let you split the UI into independent reusable pieces and think about each piece in isolation. Conceptually, components are like JavaScript functions. They accept arbitrary inputs called properties and return React elements describing what should appear on the screen. Okay. Okay. So basically, a component will take, you can give it some inputs, and then it'll say, hey, based on these inputs, this is how the component should look like. Functional and class components. The simplest way to define a component is to write a JavaScript function. Okay. So this is returning a JSX element or a JSX variable. This welcome function. It's taking props as the input, and then it's saying, hey, if that property has a name, then I'll append it to hello and then return something back, is what it's saying. Next is, it's saying this function is valid React component because it accepts a single props object argument with data and returns a React element. We call such components functional because they are literally JavaScript functions. Okay, understood. You can also use ES6 class to define a component. Okay, yeah, this is a lot better looking. So it's a class called welcome, and it extends a React component, and it has a render function, and then the render function is returning this JSX with that header tag, and looks like, yeah, I don't know where this property is defined, but this dot props is defined, but looks like this will allow you to use a property that is part of this class and basically render a header tag with hello and the name that's passed in. The above two components are equivalent from React's point of view. Classes have some additional features that we will discuss in the next sections. Until then, we will use functional components for their conciseness. Okay. So it looks like in the next set of tutorials, we'll just focus on functions, I guess. So let's see. Rendering a component. Previously, we only encountered React elements that represent DOM tags. Okay. However, elements can also represent user-defined components. Okay. Okay, so basically we can use a React component, and a JSX element can use uh, a user-defined React component. In this case, welcome is a component, and looks like it has a name property, and you can set the name property this way. When React sees an element representing a user-defined component, it passes JSX attributes to this component as a single object. We call this object props. For example, this code renders hello Sarah on the page. Okay. They're still using the okay. And this is how they use it using JXX. Let's say looks like this is a component, and then the component can be used this way is what they're saying in React. And if I want to render it to the root element, so then they're saying, hey, I can do something like that. I can pass the element as the first argument, and the second one I can pass the root element, and that's how it's being rendered. So let's see if we can look at the code in a little more detail. Again, we'll just open the HTML and JavaScript and see how it looks. HTML again just has a root tag and nothing else. And JavaScript has that function, which they're saying a function like this is a React component. And then, so they created a JSX element here, and then they're rendering it to the root element by calling the React DOM's render method. For the first argument, they're passing the element itself, and the second one, they're passing the root element. So the second part of it, okay, so we tried it in CodePen. I think they're just recapping here, like in four steps, I guess. They're saying the first one says we call React DOM. Okay, understood. And the second one, React calls welcome component with the property, okay. And then our welcome component returns hello Sarah. So this one, they're saying this one will return hello Sarah. And React DOM efficiently updates the DOM to match hello Sarah. Okay. The caveat: always start component names with a capital letter. Okay. Good naming convention, I think. So they want you to start component names with a capital letter. For example, div slash represents a DOM tag, but welcome slash represents a component to be in scope. I wonder why we can't have an end tag. I wonder if we can have a welcome and slash welcome as the component itself. Anyway, so as we go through, we might see that also. I don't want to rush. The next part of it is composing elements. So composing, okay, components can refer to other components in their, let me see if I can use the, no. components can refer to other components in their output. Components can refer to other components in their output. This lets us use the same component abstraction for any level of detail. A button, a form, a dialog, a screen. In React apps, all those are commonly expressed as components. Okay. Okay. Basically, they're saying everything is a component in React app. That's what I'm guessing by what they're saying there. The next one is, for example, we can create an app component that renders welcome many times. Okay. Oh, okay. So he's reusing the welcome component multiple times. Component. The app component it's returning a div, and it has three. It's using the welcome component 3 times inside of it. And React DOM.render. Okay, that one is the first argument again is the JSX app element, and the second one is the root. So that's what it's so I'm guessing this will just render it 3 times. So let's take a look at the code pen itself to see how it looks. Then let me open the HTML. Will be again nothing but the root tag, and yeah, and the JSX, as you can see. So each of these elements got rendered. So basically, they reuse the welcome React component to render Sarah, Cahill, and Edite, I guess. So if I want to reuse the element one more time, I can just add welcome equals BC. Then I wonder if I can do something like this. Let's see if this renders. Yeah, that renders too. I like syntax like this somehow, where I want to put I don't like the slash notation. I like to end my tags with the proper end tag, I guess. Anyway, so that said, so typically new React apps have a single app component at the very top. Okay, so they have a app shell or something like an app component at the very top. However, if you integrate React into an existing app, you might start bottom up with a small component like button and gradually work your way to the top of the view hierarchy. Okay. So in our case, we'll just create a brand new app, so we don't have to worry about something like that. Caveat: components must return a single root element. This is why we added a div to contain all the welcome elements. Okay. They're saying components must return a single root element. Oh, okay. So basically, they don't want component to return 3 of them, I think. So I doubt we can do something like this. If I comment out this, oops, I don't think there is commenting facility in CodePen. Yep, it's not there. So I can't. Doubt I'll be able to do something like this. I don't think React will like something like this. So they want everything to be return one element, and that one element can have multiple child elements. But I doubt I can do something like this. Let's see what happens. Hmm. Still working over. I think it's showing the last rendered element. So I wonder if there is an error, and if somehow, oh, so it's showing this. I wonder what that means. Unexpected identifier. So it doesn't know how to handle it, I guess. So I wonder if I delete these other ones, will it render properly? Hmm. Still doesn't know. Yeah. So basically, it doesn't like if I return another. I think if I return another welcome. Okay. Let me see if I can return another welcome name equals test. I don't, I, I don't think it liked it. CodePen is showing this error. So but if I put a div around it, I'm sure it'll work. Yeah, so it worked. So I can return. I have to return only one element. It can have bunch of child elements, but I can't return multiple elements when I render as part of the. That's what they're talking about here. Yeah, component should return a single element. So extracting components. Don't be afraid to split components into smaller components, which is a good thing. Okay. I think the more granular the component is, the better it is at rendering, I'm guessing. So don't be afraid to split components into smaller components. For example, consider this comment component. Function comment props return div class name comment, user info avatar, user info name. So it has a bunch of divs inside of the main div. So there is a component called comment, and it has all these things. So let's see. Okay. I'm going to resize this HTML once more. Okay, again, it just has the root tag. The JS code again has a big comment, and it has all these things. And let's see what else. It has a constant called comment, and it has properties date, text, author, and author again has name and avatar as properties. And React DOM. Okay, so for the React DOM, we are passing date, text. Okay, so this comment. Okay, so it's taking properties as an argument, and then okay, it's being passed date, text, author. I don't know how that works, but date, text, author. Let me look at this further. So, okay, there's the date. So we're not sending an object, are we? Oh, okay, we are sending an object. Okay. So we send an object multiple times. So you're saying date. I don't know how this translates to something like this. How do they map these two things is the question. Okay. Maybe React DOM has the smarts to handle something like this. So I'm setting the attribute to something, and then it's able to say that, okay. So let's see. It accepts author and object text string date as props, and then describes. So anytime I set something like this, it's considered a prop, I guess, a property. And then it puts that in a properties object, I'm guessing. DOM React does that automatically for you, I guess. So this component can be tricky to change because of all the nesting. And it is also hard to reuse individual parts of it. Let's extract a few components from it. First, we'll extract avatar. Okay. Okay, so they created a small component called avatar, and it can take the user property, and it's setting the avatar URL and all. So if you look at it, where is the avatar? Okay, so this one. So they made this into its own property. Okay, so they made this into its own property. Yeah, the amount, then it'll be a one-liner. Is that what it does? Okay. The avatar doesn't need to know what it is being rendered inside a comment. This is why we have given its prop a more generic name, user, rather than author. Okay. We recommend naming props from the component's own point of view rather than the context in which it is being used. Okay. We can now simplify comment a tiny bit. Okay. So it looks a lot cleaner now. Next, we will extract user info component that renders an avatar next to user's name. Okay. So user info itself is being extracted out as a component, and I'm guessing that'll in turn use avatar component, I think. This lets us simplify comment even further. Okay. So our comment has user info and user info has avatar. Okay, extracting components might seem like grunt work at first, but having a palette of reusable components pays off in larger apps. A good rule of thumb is that if a part of your UI is reused several times, button, panel, avatar, or is complex enough on its own, app, feed story, comment, it is a good candidate to be a reusable component. Props are read-only. Whether you declare a component as a function or a class, it must never modify its own props. Consider this sum function. So basically properties are read-only. So it cannot be updated is what they're saying. Such functions are called pure functions because they do not attempt to change their inputs and always return the same result for the same inputs. In contrast, this function is impure because it changes its own input. Okay. React is pretty flexible, but it has a single strict rule. All React components must act like pure functions with respect to their props. Of course, application UIs are dynamic and change over time. In the next section, we'll introduce a new concept of state. State allows React components to change their output over time in response to user actions. Network responses and anything else without violating this rule. Okay. Consider the ticking clock example from one of the previous sections. So far, we have only learned one way to update the UI. We call react dom.render to change the rendered output. So they are revisiting that example again. So in this section, we will learn how to make the clock component truly reusable and encapsulate it. It will set up its own timer and update itself every second. We can start by encapsulating how the clock looks. Okay. So they are rewriting this in a better way, I'm guessing. So they created a clock component. It's doing nothing, but it's returning a JSX, which has hello world and the local string. So it's taking a property, taking a props input. So DOM rendered new date. Okay. Okay. Tick. Okay. So the tick method itself. Okay. So basically the tick method gets called again every 1 second. When that methods get called, it's rendering the clock component, and it's updating the date property of the clock element. Okay. However, it misses a crucial requirement. The fact that clock sets up a timer and updates the UI every second should be an implementation detail of the clock. Okay, it should update itself is what they're saying. Ideally, we want to write this once and have the clock update itself. Okay. So they want to write it like this instead of calling set interval outside, I'm guessing. So to implement this, we need to add state to the clock component. Okay. State is similar to props, but it is private and fully controlled by the component. We mentioned before that components defined as classes have some additional features. Local state is exactly that, a feature available only to classes. converting a function to a class. You can convert a functional component like clock to a class in 5 steps. Okay, so this is where we are moving from a function to a class, because a class can handle a state property within inside of it much better, is what I'm guessing. But anyway, so let's look into the converting a function to a class section. You can convert a functional component like clock to a class in 5 steps. Create an ES6 class with the same name that extends react.component. Okay. Add a single empty method to it called render. Move the body of the function into the render method. Replace props with this.props in the render body. Delete the remaining empty function. We're talking about how to convert a function to a class. And basically it's a class extends a React component, and then they're returning okay. So it's rendered somewhere else, I guess. So this one just returns whatever the contents of it are, I guess. So it's just returning the JSX. So clock is now defined as a class rather than a function. Okay. Now let's see how it looks in CodePen. So this is how it looks. Let's look at the HTML. The HTML again just has only the root tag, and clock is extending a React component. It's doing it has a heading tag h1, and next to it there is a h2 tag. In the next line, I think the h2 tag is taking the property and converting it to the local string. And then let's see what function tick is doing. So the tick is using the React DOM.render method to render this clock element every 1 second. No? Okay. So there is this set interval that's getting called every 1 second. Okay. So this one extends React component, and this one is rendering. React component does nothing, but it returns what the render method of a component returns what needs to be rendered, I guess. And there is a tick method that is rendering it to the React DOM itself. And that tick function itself is getting called by set interval. Okay. Adding local state to a class. We will move the date from props to state in 3 steps. Replace this.props.date with this.state.date. Okay. So they want to handle the state within the component. So basically date needs to be updated within the component. So they're moving it. Okay. So I'm going to update it here instead of there. Let's say I want to do state. Add a class constructor. So I will add a class constructor. We'll add a class constructor. Oh, this one is taking a props. And yeah, always call super. And we set the state. Okay, initialize the state. Initialize the state, then okay. So this, okay. Then what else? So we did that. Note how we pass props to the base constructor. So it's saying note how we pass props to the base constructor. Okay, we did that. So let's go and see what is next. So class component should always call the base constructor with props. Okay. Remove the date prop from clock element. Okay. I don't like that either. So removed it. Yeah, it's also only creating this once. The tick is getting called. So even now the tick is getting called every 1 second. And then it's rendering it to the root every 1 second. But somehow this time is not getting updated. So, okay, prop. We are missing the prop, I think. Okay. We have all the code, but is it supposed to refresh it or it is getting called, but somehow okay. We'll see. Why is it not updating? Okay, let me see if their code pen is updating. The window. Okay. Theirs is not updating either. So even though the timer is getting called, the DOM is not getting updated. Maybe it's supposed to be like that. We'll see why it's supposed to be like that or why it's not supposed to be, I guess. Adding lifecycle methods to a class. So in applications with many components, it's very easy to free up resources taken by components when they're destroyed. With many components, it's very important to free up. Okay, so it's saying that we should free up resources. Okay, We want to set up a timer whenever the clock is rendered to the DOM for the first time. This is called mounting in React. Okay. You also want to clear the timer whenever the DOM produced by the clock is removed. This is called unmounting in React. We can declare special methods on the component class to run some code when a component mounts and unmounts. Okay. So basically, we want to set up the timer as soon as the component is mounted, and destroy it as soon as the component is unmounted. So let's create those methods. Okay, component did mount, component will unmount. These methods are called life cycle hooks. Yeah, okay. Tracking the life cycle of the component. Okay. The component did mount hook runs after the component output has been rendered to the DOM. Okay. So as soon as the component output has been rendered to the DOM, it will run after it gets added. This is a good place to set up a timer. Okay, agreed. So we'll have a this dot timer ID. So we want to run function every. Okay, if we want to run this tick method every 1,000 milliseconds. Okay, and the unmount, I need to delete this. So we want to clear the interval. Okay, we'll clear the interval in the unmount. Okay. So looks like this dot props and this dot state. This dot prop is set up by React itself, so you have to be careful not to create a property called props again. And this dot state has special meaning, so you have to use this dot props and this dot state um, as variables, as reserved variables, I guess, by React itself. So if you don't use something in render, it should be in the state. If you don't use something in render, it shouldn't be in the state. Okay. So basically anything that we use inside of render should be in the state. We will tear down the timer in the component unmount lifecycle hook. Okay, understood. Finally, we will implement the tick method that runs every second. Okay. So it will use this dot set state to schedule updates to the component local state. Okay. So I don't think I need this method. I'll remove this. I don't want to render anything. I'll go ahead and create a new method called tick. It doesn't take any arguments. So tick and tick, I'm going to set the state. And state, this dot set state. To set the state, or let's set this date to new date. Okay. So as soon as the component mounts, we kick off a timer. We set interval every 1 second to call the tick method. The tick method sets the state, and the components render as yeah. So basically, as soon as the state changes, we are updating what we are returning H2. So I wonder if the state is monitored at a React level, and then React looks at the state changes and then says that, hey, I need to update this component's H2 field in this case. Okay. And looks like we need to add rendering to, so is it React DOM? Okay. Render. I want to render my clock component. Second argument will be my document. I'll get the document. Second argument is that. Okay. So let's see what happens. So I'm rendering my clock element inside the root, and it's supposed to update. We'll see what happens. So I'm calling clock, this dot set state. Hmm. What is missing? Oh, I think it's supposed to be uppercase. Here, down dot render. Okay. Okay. Now I see that the time is getting updated. Now the clock ticks every second. Let's quickly recap what's going on and the order in which the methods are called. The first one, when clock is passed to React DOM render, React calls the constructor of the clock component. Since clock needs to display the current time, it initializes this dot state with an object including the current time. We will later update this state. React then calls the clock component's render method. So it's calling the constructor first and then the render method. This is how React learns what should be displayed on the screen. React then updates the DOM to match the clock's render output. React then updates the DOM to match the clock's render output. When the clock output is inserted in the DOM, React calls the component did mount. So, okay, lifecycle hook. Inside it, the clock component asks the browser to set up a timer to call tick once a second. Every second the browser calls the tick method. Inside it, clock component schedules a UI update by calling setState with an object containing the current time. Thanks to the setState call, React knows the state has changed and calls render method again. That state is called. React will take care of calling render method again to learn what should be on the screen. This time, this.state.date in render method will be different. So the render output will include the updated time. React updates the DOM accordingly. Okay. If the clock component is ever removed from the DOM, React calls component will unmount lifecycle hook, so the timer is stopped. Okay, to recap, number one, when clock is passed to React DOM.render. React calls the constructor first and then the render method. Inside the render method, okay, since clock needs to display the current time. So when clock is passed to React DOM.render, React calls the constructor of the clock component. So it's calling the constructor. Since clock needs to display the current time, it initializes this dot state with an object including the current time. We will later update this state. React then calls clock component's render. So it calls the constructor, it goes to the constructor, and then so it calls super, and then it's also setting state. React then calls the render method. So the render method is where render methods of the clock component is where React will find out, hey, what it needs to display. React then updates the DOM to match the clock's render output. Yeah. When the clock output is inserted in the DOM, React calls the component did mount lifecycle hook. Inside it, the clock component asks the browser to set up a timer to call tick once a second. Okay. So React then finds out using the render output what it needs to display. And then React takes the element and inserts it into the DOM. And as part of that, it will call component did mount lifecycle hook. Inside it, the clock component has browser to set up a timer to call tick once a second. Every second, browser calls tick method. Every second, the browser is calling the tick method. Inside it, the cloud component schedules a UI update by calling setState with an object containing the current time. Thanks to the setState call, React knows the state has changed and calls render method again. So every second the tick is called, it calls setState, and as soon as whenever setState gets called, React will call render again. And yeah, and the render method will be, this time React will compare the DOM and what changed, and then React will update the DOM accordingly. So as soon as the clock component gets removed, then React calls component will unmount. Okay. So I've gone through this multiple times, so I'll go to the next section. So using state correctly. There are 3 things you should know about set state. Do not modify state directly. Okay. For example, this will not re-render a component. So I need to use set state, I guess. Instead, use this dot set state. So set state comment hello. The only place where you assign this dot state is the constructor. Okay. So I can only initialize this dot state in the constructor. After that, I need to use the set state method. State updates may be asynchronous. React may batch multiple set state calls into a single update for performance. Because this dot props and this dot state may be updated asynchronously. Because this dot props and this dot state may be updated asynchronously, you should not rely on their values for calculating the next state. For example, this code may fail to update the counter. So they don't want you to update the counter because this is, so we're directly accessing state and updating it. So they don't like it. Okay. To fix it, use a second form of set state. Previous state props. We used an arrow function above. We used an arrow function above, but it also works with regular functions. Okay. I wonder how these arguments are passed to set state. previous state. Okay. Oh, previous state returns the entire state. I wonder if this is always the stuff that comes here is always the state. The first argument is always the state, and the second one is always props. Okay. Let's assume this is always state and this is always props. And then we can use that to update state. Okay. State updates are merged. State updates are merged. When you call set state, React merges the object you provide into the current state. When you call set state, React merges the object you provide into the current state. For example, your state may contain several independent variables. Then you can update them independently with separate set state calls. Okay. So it looks like with set state, if you have multiple properties inside your state, you can choose to update only the relevant one, and React will take care of merging it. So in the example below, looks like he's fetching some posts, and then he's dumping the post to the post one, and comments his dumping them into the comments property of the state. Okay. This merging is shallow. So this dot set state comment leaves this dot state posts intact, but completely replaces this dot state dot comments. Okay. The data flows down. Neither parent so neither parent nor child components know neither parent nor child components know if a certain component is stateful or stateless, and they shouldn't care whether it is defined as a function or a class. This is why state is often called local or encapsulated. It is not accessible to any component other than the one that owns and sets it. A component may choose to pass its state down its child components. The component may choose to pass its state down as props to its child components. It is this dot state dot date logl string. This also works for user-defined components. Formatted date equals. So I think looks like you can pass the state down to a component's children. The formatted date component would receive the date in its props and wouldn't know whether it came from clock's state, from the clock's props, or was typed by hand. Okay. This is commonly called a top-down or unidirectional data flow. Any state is always owned by some specific component, and any data or UI derived from that state can only affect components below them in the tree. If you imagine a component tree as a waterfall of props, each component state is like an additional water source that joins it at an arbitrary point but also flows down. The waterfall of props. To show that all components are truly isolated, we can create an app component that renders 3 clocks. Each clock sets up its own timer and updates independently. In React apps, whether a component is stateful or stateless is considered an implementation detail of the component that may change over time. You can use stateless components inside stateful components and vice versa. Let's open this CodePen and see. Okay. Okay. Let me take a 10-minute break. I'll be back in a minute. Okay. I am back. Okay, coming to handling events. Looks like the difference between a React event and a normal HTML event is they in normal HTML events they use all lowercase on click, and in a React event it's a camel case, as you can see. And also for a HTML event handler, we give it the function name like this, and in React you pass it an expression with the name of the method that you want it to call. And also the other difference is if you want to prevent the default, you return false with a normal um, event handler, but in React, instead of returning false, you do a prevent default. You call the prevent default method. So React defines these synthetic events according to W3C specs, so you don't need to worry about cross-border compatibility. Um, so you don't have to ever use add event listener if you're handling this synthetic events, because everything is within the React framework. So when you define a component using ES6, so when you define a component using an ES6 class, a common pattern is for an event handler to be a method on the class. For example, this toggle component renders a button that lets the user toggle between on and off states. So what they're saying is a common pattern for event handling to be a method on the class. So let's see what they mean. So in this case, so let's say the user clicked on this toggle method, no, on the toggle element itself. And to handle that, we're first of all yeah, I don't know what this means, but anyway, so looks like for every event that we handle, we have to do this binding. So then the handle method itself is setting the previous state. So I think at least the first argument is the previous state. And then the previous state, okay, it's just changing the previous state. Button on click. Okay, so button on click, this dot handle click. So this state, okay. So it sets, and then, okay, this is how they're handling the synthetic events, I guess. So this is a synthetic on-click event that looks like React allows us to use on a button element. And when the user clicks on the button, it's calling the handle click method, and then the handle click method, we are setting a toggle flag. Okay. I wonder how this looks. Let me see how this looks. Let's see what the HTML looks like. Again, it's just a simple div root, div with an ID of root. And this one has a button with text on. So when I click on it, I think this one toggles, I guess. Yep, it toggles to off. So toggle, okay, is toggle on, okay. Based on if it's on or off, we display the string, I guess, on or off inside of the button, and I click on it. So when as soon as I click on it, this dot so as soon as I click on the on button, the handler, the event will be processed, and this dot handle click method gets called, and then that one is going to set the state, and as soon as the state changes, uh, React will take care of processing the state change, and because this is in an expression, it will say, hey, this one changed and change, so I want to display on or off based on the state. Okay. Whoa, made it full screen now. Okay, use a little more. Okay. So now that I resized it, okay, basically that's how the event on click is handled. You have to be careful about the meaning of this in JSX callbacks. So you have to be careful about meaning of this in JSX callbacks. In JavaScript, class methods are not bound by default. What does that mean? If you forget to bind this dot handle and pass it to onClick, this will be undefined. Okay. So basically what they're saying is this binding is necessary. So for everything, every time we want to handle an event, looks like the the event handler needs to bind to this. Oh, this is not React specific behavior. It is a part of how functions work in JavaScript. Okay. Generally, if you refer to a method without parenthesis after it, such as onClick equals this dot handle click, you should bind that method. Okay. So best practice is, yeah. So basically, whenever you have a method like this, without parenthesis, you should bind that. Okay. calling bind annoys you, there are two ways you can get around this. If you're using the experimental property initializer syntax, you can use property initializers to correctly bind callbacks. Why is this experimental? So, what is this doing? Okay, class properties. Bound function. Anyway, we won't use this experimental property initializer syntax because it looks messy to me. This syntax is enabled by default and create React app. So let's look at this again. So below is a class with 4 class properties which will be transformed. Okay, so this is the one. This dot instance property equals Borg static class properties. Static property equals school. Installation. Via CLI, via Node API. Okay, this is not yet a standard, not even. Okay. So Babel will take care of. Okay. Anyway, so the create React app, it's automatically supported. Okay. Syntax, you can use an arrow function in the callback. Okay. Okay, that sounds good. I like this. So this syntax is much better than that binding thing because you don't want to forget to bind and then it'll end up causing other problems. So this syntax is, I like this, ES6 syntax, okay. The problem with this syntax is that a different callback is created each time logging button renders. Oh. In most cases, this is fine. However, if this callback is passed, as a prop to lower components. This callback. Those components might do an extra re-rendering. We generally recommend binding in the constructor or using property initializer syntax to avoid this sort of performance problem. Okay, so we'll just use a property initializer, I guess. So let's see. So that's saying it's still, let me go back. This is still not a standard, huh? This is not yet a standard and not even have brought to TC39 at the time of writing. Still stuck that stage 2. Okay. How come it was here 1 year ago and stating that it is part of ES 2016? Don't even understand why people are so possessed with new class syntactic sugar. Fundamentally, it is not class but still prototype based. This is why making the property declared inside the class is not considered at the beginning, because it causes more confusion than benefits. Methods are in prototype while properties are on each instance. Not to mention the class syntax make it look like it's hosting, but in fact it is not, and also quite confusing as well. Nice job making more confusions to noob JavaScript developer. Okay. I felt this was initially, I was like, why use this syntax? It's not just going to confuse everyone. Okay. Okay. Still in stage 2. Okay. We'll just stick with the bind notation for now, and then see. We have to move to this at a later time. Going to the next chapter, conditional rendering in React. You can create distinct components that encapsulate behavior you need. Then you can render only some of them, depending on the state of your application. Conditional rendering in React works the same way conditions in JavaScript. Use JavaScript operators like if or the conditional operator to create elements representing the current state, and let React update the UI to match them. Consider these two components, user greeting and guest greeting. Okay. We'll create a greeting component that displays either of these components depending on whether a user is logged in. If the user is logged in, we'll show, okay. Try it in CodePen, okay. Takes forever to repaint. Okay, let me check up. Let me check. So again, the HTML is pretty straightforward. So there's nothing in it. So okay. So let's see if we change this to true, and now it should say welcome back. Okay. So based on the if statement is changing the greeting. So I change this to true or false. Okay. So it's a property. The property is coming through, and it's checking if the property is logged in. Then, yep. If it is the user is logged in, then it's saying I don't know what this showed up. Reduce the size of the console and the rendered HTML. So let's see. Okay, so the user greeting says welcome back, and the guest greeting says please sign up. So based on that, it's changing it. This example renders a different greeting depending on the value of is logged in property. So next one is element variables. You can use variables to store elements. Okay. This can help you conditionally render a part of the component while the rest of the output doesn't change. Consider these two components representing logout and login buttons. Function login button, and then when it's clicked, it's calling props.onClick. A logout button, when it's clicked, it's calling props.onClick. Okay, both of them are calling some props.onClick. In the example above, we will create a stateful component called login control. Okay. It will render either login or logout depending on its current state. It will also render a greeting from the previous example. So it will render either login or logout depending on its current state. It will also render a greeting from the previous example. Class login control extends React component. It has a constructor where the login click and the logout click handlers are set, and it's setting a default state of false. And when the login is clicked, I think they're setting the state to the is logged in state to true. When logout is clicked, they're setting the logged in state to false. And there is a render. Okay, so render is checking, hey, what is the state? And then based on the state, it's either showing if the user is logged in, we're showing the log out button. If the user is logged in, then we are showing the, if the user is logged out, we are showing the login button. So we return, okay, the render is also returning greeting is logged in. And there is, oh, there is the button, okay. Okay, so this is what they're talking about here. Element variables. So basically they're saying element variables can store elements, so you can reuse it. Okay. So this is a element variable or what? Okay, so we have a button variable and it's storing the JSX element itself, and based on if the user is logged in or not, we are showing it. Okay. Understood. While declaring a variable and using an if statement is a fine way to conditionally render a component. Sometimes you might want to use a shorter syntax. There are a few ways to inline conditions in JSX explained below. Inline if with logical ampersand operator. You may embed any expression in JSX by wrapping them in curly braces. This includes JavaScript logical ampersand operator. What does the and mean here? And curly braces. The JavaScript logical ampersand operator. It can be handy for conditional including an element. Okay. Const messages equals react, react. So render mailbox. Unread messages equals messages. Okay. So there are 3 of them in an array, 3 messages, and we're trying to render them. It goes to mailbox and then props.unread messages. Unread messages is greater than 0. Okay, let's try this code in CodePen because it's a little messy. So let's try to look at it in CodePen. There's nothing in HTML, so most of the code is here. So I have 300 messages. So let's say I empty it out. What will I see? Hello is the only thing I'm seeing. So the 100 messages tag, whatever that is not even showing up. You have 100 message. Don't understand the purpose. Okay, so if this, then this. Really bad way of doing it, I think, but anyway. It doesn't show that itself, but at least if there is something, then it shows that, hey, there is 100 message. Try it on CodePen. Okay. It works because in JavaScript, true and end expression always evolves to expression. And false and expression always evaluates to false. Therefore, if the condition is true, the element right after ampersand will appear in the output. If it is false, React will ignore and skip it. Inline if else with conditional operator. Another method for conditional rendering elements inline is to use JavaScript conditional operator, condition true false. In this example below, we use it to conditionally render a small block of text. It can also be used for larger expressions, although it is less obvious what's going on. Okay, so basically he's using this conditional operator, which is pretty common. It can also be used for larger expressions, although it is less obvious what's going on. Okay, he used it here also. Just like in JavaScript, it is up to you to choose an appropriate style based on what you and your team consider more readable. Also remember that whatever conditions become too complex, it might be a good time to extract a component. So preventing component from rendering in rare cases, you might want a component to hide itself, even though preventing component from rendering in rare cases, you might want a component to hide itself, even though it was rendered by another component. To do this, return null instead of its render output. In this example below, the warning banner is rendered depending on the value of the prop called warn. If the value of prop is false, then component does not render. Okay. So this is what he's talking about. So this is one way to prevent rendering of a component. So okay, so this is where they're setting it. If you set the warn property to null, then it's not rendered. Okay, show warning. Okay, so that is pretty straightforward. Returning null from a component's render method does not affect the firing of the component's lifecycle methods. For instance, component will update and component did update. Whoa. Component will update and component did update will still be called. Lists and keys. first, let's review how you transform lists in JavaScript. Given the code below, we use a map function to take an array of numbers and double their values. Okay. In React, transforming arrays into lists of elements is nearly identical. Okay. So this one resulted in this. So they're saying in React, transforming arrays into lists of elements is nearly identical. Let's see what that means. Rendering multiple components. You can build collections of elements and include them in JSX using curly braces. You can build collections of elements and include them in JSX using curly braces. Okay. Below, we loop through the numbers array using the JavaScript map function. We return an li element for each item. Finally, we assign the resulting array of elements to list items. We loop through the numbers array using the map. Okay. We include the entire list items array inside a UL element and render it to the DOM. Okay. This is a little React takes care of handling array, I guess. Let's see. Okay. Take out the UL, what will happen? I think it's okay. Put it in a div, what will happen? Okay. Somehow it's able to handle it. Huh? Okay. Unordered list and list items, it's somehow working. Okay. So basic list component. Usually you would render lists inside a component. We can refactor the previous example into a component that accepts an array of numbers and outputs an unordered list of elements. Function number list props. Const numbers equal props.numbers. Const list items equals numbers.map number to blah blah blah. Okay, so basically you have a bunch of numbers, and then it creates a list. Items is nothing but an array. Okay. And then we return that. If you have numbers 1, 2, 3, 4, 5, the number list of numbers, sending numbers, will take that, and then it'll return a JSX. This one is returning a JSX. When you run this code, you'll be given a warning that a key should be provided for a list items. When you run this code, you'll be given a warning that a key should be provided for list items. A key is a special string attribute you need to include when creating lists of elements. We'll discuss why it's important in the next section. Let's assign a key to our list items inside numbers.map and fix the missing key issue. Number to string number. Let's see if it's a HTML standard to include MDN. We'll go to the MDSN and look at the li tag and see what they're talking about. Mm-hmm. Okay. Anyway, so I don't know what the key, what this key means, but let's see. When you run this code, you'll be given a warning that a key should be provided for a list item. So key is a special string attribute you need to include when creating lists of elements. We'll discuss why it's important in the next section. Let's assign a key to our list items, including numbers.map, and fix the missing key issue. Okay. We added this. Then what happened? Keys. Oh, this is mainly for React, I guess. Keys help React identify which items have changed, are added or removed. Keys should be given to elements inside the array to give elements a stable identity. Okay. The best way to pick a key is to use a string that uniquely identifies a list item among its siblings. Most often, you would use IDs, your data IDs from your data as keys. Okay, makes sense. When you don't have stable IDs for rendered items, you may use the item index as a key as last resort. Okay. Only do this if items have no stable IDs. Okay. We don't recommend using indexes for keys if the items can reorder, as that would slow. You may read an in-depth explanation about why keys are necessary if you're interested. Extracting components with keys. Keys only make sense in the context of the surrounding array. Okay, keys only make sense in the context of surrounding array. For example, if you extract a list item component, you should keep the key on list item elements in the array rather than on the root li element in the list item. Okay, let's see what they're talking about. Okay, list item. Okay. So if it's a list item, just put it on the list item itself is what they're saying. Yeah, you don't have to put it on the element that's inside the list item. Okay. Correct key usage. Okay, this makes sense. So basically the list item itself, inside of it, we shouldn't use a key, but when we go through the array, we can assign a key to it because numbers here are unique, or at least assuming numbers here are unique, number to string will be unique. Okay. A good rule of thumb is that elements inside the map. Okay. A good rule of thumb is elements inside map call need keys. Okay. Key must only be unique among siblings. Keys must only be unique among siblings. Keys used within arrays should be unique among their siblings. Okay, keys used within arrays should be unique among their siblings. However, they don't need to be globally unique. We can use the same keys when we produce two different arrays. Okay, they should be unique when it comes to siblings, but between two different okay, content sidebar. Yeah, there are two JSX elements here called sidebar and const and content, and both of them are reusing a key called post ID. You can do that without a problem. Okay. Keys serve as a hint to React, but they don't get passed to your components. So basically, keys are mainly for React. If you need the same value in your component, pass it explicitly as a property with a different name. Okay. So yeah, key is mainly used by React, but you can use the same thing that you're assigning key to a different property, and then that can be used also. The example above, the post component can read props.id, but not props.key. Embedding map in JSX. The examples above, we declared a separate list items variable and included it in JSX. Okay. JSX allows embedding any expression in curly braces. So we could inline the map result. Function number list props const numbers equals props dot numbers return ul unordered list. Oh, okay. So you can put this in an expression also, is what you're saying, instead of creating a different method like what we did before. And okay. Sometimes this results in clearer code, but this style can also be abused. Like in JavaScript, it is up to you to decide whether it is worth extracting a variable for readability. Keep in mind that if the map body is too nested, it may, it might, it might, it might be a good time to extract a component. Okay, understood. Forms. HTML form elements work a little bit differently from other DOM elements in React because form elements naturally keep some internal state. For example, this form in plain HTML accepts a single name. This form has the default HTML form behavior of browsing to a new page when the user submits a form. If you want this behavior in React, it just works. But in most cases, it's convenient to have a JavaScript function that handles the submission of the form and has access to the data that the user entered in the form. The standard way to achieve this is with a technique called controlled components. Control components in HTML, form elements such as input, text area, select typically maintain their own state and update it based on user input. In React, mutable state is typically kept in the state property of components, only updated with set state. Again, saying in HTML, form elements such as input, text area, select typically maintain their own state and update it based on user input. In React, mutable state is typically kept in the state property of components and only updated with set state. we can combine the two by making the React sorry we can combine the two by making the React state be the single source of truth. Then the React component that renders the form also controls what happens in that form on subsequent user input. An input form element whose value is controlled by React in this way is called controlled component. For example, if we want to make the previous example log the name it is submitted, we can write the form as a control component. Okay. Class name form extends React component. Constructor props. Okay. Doing some binding in the constructor, and looks like the value is stored in the state itself. Okay. Yeah, whenever we detect something change, we are setting the state. So handle submit is doing something. So form on submit equals this dot handle submit. Value this dot state dot value on change handle change. So okay, so this is how we control the form's input and what should happen when something changes. Okay. So there is no on submit, right? Handle submit is also there. When is that get called? Okay. So if it because it's type submit. Okay, let's try this and see how this behaves. Okay. Let me submit an empty one and see. An embedded page at blah said the name was submitted. Oh, it's sending an alert message. Okay, alert. A name was submitted. Okay. So let's say I do something like that and click on submit. A name was submitted HH. Okay. When the form is submitted, oh, okay. So here it is. So here we are saying that, hey, on submit, let us handle the on submit. So on submit, we are storing, as the name is changing, we are storing the value of the input in the state's value. That's how we're doing it. Okay. Since the value attribute is set on our form element, the displayed value will always be this dot state dot value, making the React state the source of truth. Since handle change runs on every keystroke to update the React state, the displayed value will update as the user types. With a control component, every state mutation will have an associated handler function. This makes it straightforward to modify or validate user input. For example, if we wanted to enforce that names are written with all uppercase, we could write handle change as to uppercase. Okay. The text area tag. In HTML, the text area element defines the text by its children. In React, a text area uses a value attribute instead. This way, a form using a text area can be written very similarly to a form that uses a single line input. Okay. Notice that this .stateword value is initialized in the constructor so that the text area starts off with some text in it. Okay. The select tag in HTML, select creates a drop-down list. For example, this HTML creates a drop-down list of flavors. Okay. Note that the coconut option is initially selected. Okay. Because of the selected attribute. React, instead of using this selected attribute, uses a value attribute on the root select tag. This is more convenient in a control component because you only need to update it in one place. For example, okay, showing an example and render select option, okay, the value. So React takes care of this, translating this value attribute and putting it in coconut or something like that. Okay. Overall, this makes it so that input type text, text area select all work very similarly. They all accept a value attribute that you can use to implement a control component. Handling multiple inputs. So when you need to handle multiple controlled input elements, you can add a name attribute to each element and let the handler choose what to do based on the value of event.target.name. For example, we have a class reservation and it has state. Inside its state, we are maintaining easygoing and number of guests. And we are saying we have a handler called handle input change. That handle input change takes the event and then okay. So it's doing other stuff, which, okay, so let's see. Oh, it's a type of checkbox. On change, it's handle the input changed. Okay, let's open this in CodePen to understand this better. So what are they saying? Handling multiple inputs. When you need to handle multiple controlled input elements, you can add a name attribute to each element and let the handler function choose what to do based on the value of event.target.name. Okay. So is both of them calling handle input changeover. You have a form and input. Okay. There is one handle input change. Okay. Other one. So both of them are calling handle input change. Then I think handle input change is going to check if it is a checkbox. It's setting the value of that particular name. But he is going or number of guests. Okay. So if number of guests changes, then it'll set the state of that. Otherwise, it's setting the state of he's going. So it'll either set this or this. Okay, understood. Note how we used ES6 computed property name syntax to update the state key. Okay, so it's talking about this ES6 computed property. If you put it in a square brackets, oh, it's listed here also. It is equivalent to this ES5 state. Okay. Also, since set state automatically merges a partial state into the current state, we only need to call it with the changed parts. Set state automatically merges partial state. Okay. So it's only changing the whatever is needed to be changed, I guess. Alternatives to control components. It can sometimes be tedious to use control component because you need to write an event handler for every way your data can change and pipe all of the input state through a React component. This can become particularly annoying when you're converting a pre-existing code base to React or integrating React application with a non-React library. In these situations, you might want to check out uncontrolled components, an alternative technique for implementing inputs. Okay, let's see. to increase the font size. Okay, the next chapter is lifting state up. Often several components need to reflect the same changing data. We, ref- we recommend lifting the shared state up to their up to their closest common ancestor. Let's see how this works in action. In this section, we will create a temperature calculator that calculates whether the water would boil at a given temperature. We will start with a component called boiling verdict. It accepts the Celsius temperature as a property and then prints whether it is enough to boil the water. Okay, it's pretty straightforward. It's returning a JSX, which says the water would boil if it is above 100 degrees. Otherwise, it says the water would not boil. Next, we will create a component called calculator. It renders an input that lets you enter the temperature and keeps its value in this.state.temperature. Additionally, it renders the boiling verdict for the current input value. Class calculator extends React component constructor. Okay, so it's binding the change event and state, initializing the state. Okay. So when the state changes, I think the temperature is set. And when render is called, it's doing okay. So boiler verdict is being sent a temperature value, and it takes the value. If it's greater than 100, then it's doing that. So this is what this is. This is the one that's showing either if the water would boil or not boil. So where are we reusing it? What are we? What is it saying? Lifting state. So he's taking state from one. He's taking state from the input and passing it to boiler verdict. Is that what is called lifting the state up? So both of them are sharing a state called temperature. So what he's saying is you need to lift up temperature to something that's common to both of them. So looks like calculator is something that's common to both of them. So we have a state called temperature in calculator, and that state is shared between input and boiling verdict. Okay, that's pretty simple. Adding a second input. Adding a second input on. Okay. Our new requirement is that in addition to a Celsius input, we provide a Fahrenheit input, and they're kept in sync. We can start by extracting a temperature input component from calculator. We will add a new scale property to it that can either be centigrade or Fahrenheit. Okay, we have scales, temperature input. So earlier, temperature input was just the input field. So now it looks like he'll replace this with the temperature component. Okay. So temperature input. Temperature input is looking for change events, and then I don't know where the scale names is being used. Oh, okay, here it is. So enter temperature in scale. Okay, so which scale do we want them to enter it in? Input value equals temperature on change this dot handle change. Okay, but where are they? Where are we allowing them to change the state? Okay, so they pass it as a parameter. Okay, so it's a property. So this element gets passed. What kind of input we are supposed to take? Okay, so the temperature input element either takes um, at instantiation itself. They have to tell us is it in centigrade or is it in Fahrenheit. We can now change the calculator. Okay, the calculator now has two inputs, one with the scale of f c and one with f. But we are not rendering the boiling verdict yet, I think. Okay, so let's see what this is doing. It does nothing yet, which is expected. Not going to tell me if it is what the boiling verdict is. Just takes. Yeah, it's just an input field. That's it. Nothing more than that. It's saying what we know already. It's saying that they are not in sync. When I update one, the other one is not updating, and not only that, the boiling verdict is not showing up. So writing conversion functions. First, we will write two functions to convert from Celsius to Fahrenheit and back. Okay, so it's writing like 2 Celsius. It's writing two functions, one called 2 Celsius and the other one called 2 Fahrenheit. These two functions convert numbers. We will write another function that takes a string temperature and a converter function as arguments and returns a string. We will use it to calculate the value of one input based on the other input. Okay. It returns an empty string on an invalid temperature, and it keeps the output rounded to the third decimal. Okay. Try convert. Okay. So temperature. Okay. So if input is not a number, then we return. Otherwise, we convert. Constant rounded, math.round, output. Okay. Rounded to string. For example, try convert ABC to cells returns an empty string. Try convert 10.22 to Fahrenheit returns 50.396. F minus 32 times 5 by 9. F minus 32 times 5 by 9. Lifting state up. Currently, both temperature input components independently keep their values in the local state. However, we want these two inputs to be in sync with each other. When we update the Celsius input, the Fahrenheit input should reflect the converted temperature and vice versa. In React, sharing state is accomplished by moving it up to the closest common ancestor of the component that needs it. This is called lifting state up. We will remove the local state from the temperature input and move it into the calculator instead. If the calculator owns the shared state, it becomes the source of truth for the current temperature in both inputs. It can instruct them both to have the values that are consistent with each other. Since the props of both temperature input components are coming from the same parent calculator component, the two inputs will always be in sync. Let's see how this works step by step. First, we will replace this.state.temperature with this.props.temperature in the temperature input component. For now, let's pretend this.props.temperature already exists, although we will need to pass it from calculator in the future. We know that props are read-only. So when the temperature was in the local state, the temperature input could just call this.setState to change it. However, now that the temperature is coming from the parent as a prop, the temperature input has no control over it. In React, this is usually solved by making a component control. Just like the DOM input accepts both a value and an on-change prop, so can custom temperature input accept both temperature and on temperature change props with its parent calculator. Now, Now, when the temperature input wants to update its temperature, it calls this.props.on temperature change. Note that there is no special meaning to either temperature or on temperature change prop names in custom components. We could have called them anything else, like name them value and on change, which is a common convention. The on temperature change prop will be provided together with the temperature prop by the parent calculator component. It will handle the change by modifying its local state, thus re-rendering both inputs with the new values. We will look at the new calculator implementation very soon. Before diving into the changes in calculator, let's recap our changes to temperature input component. We have removed the local state from it, and instead of reading this.state.temperature, we now read this.props.temperature. Instead of calling this .setState, when we want to make a change, we now call this.props.onTemperature change, which will be provided by the calculator. Okay. Basically, the handle change is calling something called on temperature change. And looks like there is a property called temperature now. Okay, let's see what else it's doing. Basically, the temperature is being passed by the calculator component. Now let's turn to the calculator component. We will store the current input's temperature and scale in its local state. This is the state we lifted up from the inputs. And it will serve as the source of truth for both of them. It is the minimal representation of all data. It is the minimal representation of all the data we need to know in order to render both inputs. For example, if we enter 37 into the Celsius input, the state of the calculator component will be okay. If we later edit Fahrenheit to be 212, the state of the calculator will be so and so. So we could have stored the value of both inputs, but it turns out to be unnecessary. It is enough to store the value of the most recently changed input and the scale that it represents. We can then infer the value of the other input based on the current temperature and scale alone. The inputs stay in sync because their values are computed from the same state. So a new state, and we have temperature and scale, and then we have so whenever Celsius changes, we set state, and then whenever Fahrenheit changes, we set state. So render, okay, temperature, Celsius. Const Fahrenheit equals scale equals C, try convert. Okay. What is on temperature change? Who provides that? You don't have anything called on temperature change. Oh, it's a property? Okay. Heat or target dot value. Hmm. I do not understand this part. On temperature change, you're saying you're setting, you're saying handle Fahrenheit. Let's say I started typing something. Will it trigger on temperature change? Will that call on Fahrenheit change and that sets the state? And that in turn calls render, and render takes it and then gets the temperature and it calculates Celsius and Fahrenheit. Note that there is no special meaning to either temperature or on temperature change custom components. We could have called them anything else. passing it a value basically. So let's see what handle does. Now, no matter which input you edit, this.state.temperature and this.state.scale in the calculator get updated. One of the inputs gets the value as is, so any user input is preserved. The other input value is always recalculated based on it. Let's recap what happens when you edit an input. React calls the function specified onChange on the DOM input. In our case, this is handle change method in the temperature input. Handle change method in the temperature input component calls this.props.onTemperature change with the new desired value. Its props, including on temperature change, were provided by its parent, the calculator. When it previously rendered, the calculator has specified that on temperature change of the Celsius temperature input is the calculator's handle Celsius method. And on temperature change of the Fahrenheit temperature input is the calculator's handle Fahrenheit change method. So either of these two calculator methods gets called depending on which input we edit. Inside these methods, the calculator component asks React to re-render itself by calling this.setState with the new input value and the current scale of the input we just edited. React calls the calculator component's render method to learn what the UI should look like. The values of both inputs are recomputed based on the current temperature and the active scale. The temperature conversion is performed here. React calls the render methods of the individual temperature input components with their new props specified by the calculator. It learns what their UI should look like. React DOM updates the DOM to match the desired input values. The input we just edited receives its current value. And the other input is updated to the temperature after conversion. Every update goes through the same steps so the inputs stay in sync. Okay. Lessons learned. There should be a single source of truth for any data that changes any data that changes in a React application. Usually the state is usually the state is first added to the component that needs it for rendering. Then if other components also need it, you can lift it up to their closest common ancestor instead of trying to sync the state between the two different components. You should rely on the top-down data flow. Lifting state involves writing more boilerplate code than two-way binding approaches. But as a benefit, it takes less work to find and isolate bugs. Since any state lives in some component and the component alone can change it, the surface area for bugs is greatly reduced. Additionally, you can implement any custom logic to reject or transform user input. If something can be derived from either props or state, it probably shouldn't be in the state. For example, instead of storing both Celsius value and Fahrenheit value, we store just the last edited temperature and its scale. The value of the other input can always be calculated from them in the render method. This lets us clear or apply rounding to the other field without losing any precision in the user input. When you see something wrong in the UI, you can use React developer tools to inspect the props and move up the tree until you find the component responsible for updating the state. This lets you trace the bugs to their source. Composition versus inheritance. React has a powerful composition model, and we recommend using composition instead of inheritance to reuse code between components. In this section, we will consider a few problems where developers new to React often reach for inheritance and show how we can solve them in composition. Containment. Some components don't know their children ahead of time. This is especially common for components like sidebar or dialog that represent generic boxes. We recommend that such components use the special children prop to pass children elements directly into their output. Okay. Okay. So containment. Use containment if we don't know who the children are. So this lets other components pass arbitrary children to them by nesting the JSX. Okay. So this can be arbitrary. So the fancy border can be used in different ways, and then you can pass something into it. Anything inside the fancy border JSX tag gets passed into the fancy border component as a children prop. Since fancy border renders props.children inside a div, the passed elements appear in the final output. While this is less common, sometimes you might need multiple holes in a component. In such cases, you may come up with your own convention instead of using children. So split pane, left, right. Okay. Okay. So if I want to include the left here and right here, okay. So we want contacts in the left pane and chat in the right one, I think. Try it on CodePen. React elements like contacts and chat are just objects. So you can pass them as props like any other data. Specialization. Sometimes we think about components as being special cases of other components. For example, we might say that a welcome dialog is a special case of a dialog. In React, this is also achieved by composition, where a more specific component renders a more generic one and configures it with props. Function dialog. Function dialog props. Return. Fancy border, props title, props message. Okay. So this is another way to do it. Composition works equally well for components defined as classes. Composition works equally well for components defined as classes. Dialog. Class signup dialog extends React component. Constructor. Composition works equally well for components defined as classes. Class signup dialog extends React component. Okay. So basically inside the dialog, props.children. Okay, so it has a fancy border heading and everything, and then the children, whatever children gets passed is being added here. Handle change, set state. Okay. So what about inheritance? As at Facebook, we use React and thousands of components, and we haven't found any use cases where we would recommend creating component inheritance hierarchies. Props and composition give you all the flexibility you need to customize a component's look and behavior in an explicit and safe way. Remember that components may accept arbitrary props, including primitive values. React elements or functions. If you want to reuse non-UI functionality between components, we suggest extracting it into a separate JavaScript module. If you want to reuse non-UI functionality between components, we suggest extracting it into a separate JavaScript module. The components may import it and use that function object or a class without extending it. Thinking in React. React is, in our opinion, the premier way to build big, fast web apps in JavaScript. It has scaled very well for us at Facebook and Instagram. One of the many great parts of React is how it makes you think about apps as you build them. And this document will walk you through the thought process of building a searchable product data table using React. Start with a mock. Imagine that we already have a JSON API and a mock from our designer. The mock looks like this. Our JSON API returns some data that looks like stocked false. Okay. Step one, break the UI into a component hierarchy. So a search window, a checkbox, um, column heading, and category, and the items inside the category. Step one, break the UI into a component model. Step one, break the UI into a component hierarchy. The first thing you'll want to do is draw boxes around every component and subcomponent in the mock and give them all names. If you're working with a designer, they may already have done this, so go talk to them. Their Photoshop layer names may end up being the names of your React components. But how do you know what should be in its own component? Just use the same techniques for deciding if you should create a new function or object. One such technique is the single responsibility principle. That is, a component should ideally only do one thing. If it ends up growing, it should be decomposed into smaller components. Since you're often displaying a JSON data model to a user, you'll find that if your model was built correctly, your UI will map nicely. That's because UI and data models tend to adhere to the same informative architecture, which means the work of separating your UI into components is often trivial. Just break it up into components that represent exactly one piece of your data model. Since you're often displaying a JSON data model to a user, you'll find that if your model was built correctly, your UI and therefore your component structure will map nicely. That's because UI and data models tend to adhere to the same information architecture, which means the work of separating your UI into components is often trivial. Just break it up into components that represent exactly one piece of your data model. So you'll see here that we have 5 components in our simple app. We have italicized data each component represents. So it looks like one of the components, filterable product table orange, contains the entirety of the example. Search bar blue receives all user input. Product table green displays the filters, displays and filters the data collection based on user input. Product category row displays a heading for each category. Product row displays a row for each product. If you look at product table, you'll see that the table header containing the name and price labels isn't its own component. This is a matter of preference, and there is an argument to be made either way. For this example, we left it as part of the product table because it is part of rendering the data collection, which is product table's responsibility. However, if this header grows to be complex, i.e., if we were to add affordances for sorting, it would certainly make sense to make this its own product table header component. Now that we've identified the components in our mock, let's arrange them into a hierarchy. This is easy. Components that appear within another component in the mock should appear as a child in the hierarchy. Step 2. Build a static version of build a static version in React. Now that you have your component hierarchy, it's time to implement your app. The easiest way is to build a version that takes your data model and renders the UI but has no interactivity. It's best to decouple these processes because building a static version requires a lot of typing and no thinking, and adding interactivity requires a lot of thinking and not a lot of typing. We'll see why. To build to build a static version of your app that renders your data model, you'll want to build components that reuse other components and pass data using props. Props are a way of passing data from parent to child. If you're familiar with the concept of state, don't use state at all to build this static version. State is reserved only for interactivity, that is, data that changes over time. Since this is a static version of the app, you don't need it. You can build top down or bottom up. This is that is, you can either start with building the components higher up in the hierarchy or the ones lower in it. In simpler examples, it's usually easier to go top down, and on a larger projects, it's easier to go bottom up and write tests as you build. At the end of this step, you'll have a library of reusable components that render your data model. The components will have render methods since this is a static version of your app. The component at the top of the hierarchy will take your data model as a prop. If you make a change to your underlying data model and call React DOM.render again, the UI will be updated. It's easy to see how your UI is updated and where to make changes, since there's nothing complicated going on. React's one-way data flow, also called one-way binding, keeps everything modular and fast. Simply refer to the React docs if you need help executing this step. A brief interlude. Props versus state. There are two types of model data in React: props and state. It's important to understand the distinction between the two. Skim the official React docs if you aren't sure what the difference is. Step 3. Identify the minimal but complete representation of UI state. To make UI interactive, you need to be able to trigger changes to your underlying data model. React makes this easy with state. To build your app correctly, you first need to think of the minimal set of mutable state that your app needs. The key here is don't repeat yourself. Figure out the absolute minimal representation of the state your application needs and compute everything else you need on demand. For example, if you're building a to-do list, just keep an array of the to-do items around. Don't keep a separate state variable for the count. Instead, when you want to render the to-do count, simply take the length of the to-do items array. Think of all of the pieces of data in our example application we have. The original list of products, the search text the user has entered, the value of the checkbox, the filtered list of products. Let's go through each one and figure out which one is state. Simply ask 3 questions about each piece of data. Is it passed in from a parent via props? If so, it probably is in state. Does it remain unchanged over time? If so, it probably is in state. Can you compute it based on any other state or props in your component? If so, it is in state. So the original list of product is passed in as props, so that's not state. The search text and the checkbox seem to be state since they change over time and can be computed and can't be computed from anything. And finally, the filtered list of products is in state because it can be computed by combining the original list of products with the search text and value of the checkbox. So finally, our state is the search text the user has entered, the value of the checkbox. Identify where your state should live. Okay, we've identified what the minimal set of app state is. Next, we need to identify which component mutates or owns this state. Remember, React is all about one-way data flow down the component hierarchy. It may not be immediately clear which component should own what state. It is often the most challenging part for newcomers to understand. So follow these steps to figure it out. For each piece of state in your application, identify every component that renders something based on that state. Find a common owner component, a single component above all the components that need the state in the hierarchy. Either the common owner or another component higher up in the hierarchy should own the state. If you can't find a component where it makes sense to own the state, create a new component simply for holding the state and add it somewhere in the hierarchy above the common owner component. Let's run through this strategy for our application. Product table needs to filter the product list based on state and search bar. And search bar needs to display the search text and checked state. The common owner component is filterable product table. It conceptually makes sense for the filter text and checked value to live in filterable product table. Cool. So we've decided that our state lives in filterable product table. First, add an instance property this.state equals filter text in stock only equals false to filterable product tables constructor to reflect the initial state of your application. Pass filter text and in stock only to product table and search bar as a prop. Finally, use these props to filter the rows in product table and set the values of the form fields in search bar. You can start seeing how your application will behave. Set filter text to ball and refresh your app. You'll see the data table is updated correctly. So far, we've built an app that renders correctly as a function of props and state flowing down the hierarchy. Now it's time to support data flowing the other way. The form components deep in the hierarchy need to update the state in filterable product table. React makes this flow explicit to make it easy to understand how your program works. But it does require a little more typing than traditional two-way binding. If you if you try or type if you try to type or check the box in the current version of the example, you'll see that React ignores your input. This is intentional, as we have set the value prop of the input to always be equal to the state passed in from the filterable product table. Let's think about what we want to happen. We want to make sure that whenever the user changes the form, we update the state to reflect the user input. Since components should only update their own state, filterable product table will pass callbacks to search bar that will fire whenever the state should be updated. We can use the onChange event on the inputs to be notified of it. The callbacks passed by filterable product table will call setState and the app will be updated. Though this sounds complex, it's really just a few lines of code. And it's really explicit how your data is flowing throughout the app. Mhm. Let's look at the code. What's he talking about? Okay, let's see. This is the parent component. This is the one it's rendering. Okay, let's see. So you're saying filterable product, and then we are passing it. So this is the parent component of everything. So let's see what he is doing. Okay, so this one has a search bar, which is this, and it has a product table. Oh, so actually search bar is both that and this also, the checkbox also. And the product table is the rest of it. And then search bar has something else also. I think search bar, okay, so anyway, for this one, we are passing in the filter text. We are passing in, if it is in stock, on filter text input. Also, we are trying to see how it should be handled. So on filter text input, I'm guessing it'll be called by search bars whenever it changes. So let's verify that search bar should call on filter text input. Let's see, search bar. Okay, search bar. So search bar should call on filter. Okay, it is calling on filter text input. Whenever data changes there, it's calling that. And that turns around and calls handle filter text input, which is here, and that is setting the filter text. Okay. Basically, whatever changes happen, we say, hey, we want to handle this master, this parent element wants to handle it, and then it sends it back to the filter text property. So let's see what search bar is doing with filter text. So search bar is okay. So basically, because it's a controlled component, we take care of the value. We set the value. Okay. So product table. So let's say the user changed something. So okay, but how does filtering happen? Where does filtering happen? So we're passing it the entire product. We're passing it filter text and in stock. So product table is responsible for filtering it. Let's see what product table is doing with the okay, product table. The product table Okay, it only has render, blah, blah, blah. So it has, so the rows are rendered, I guess. So let's see what happens. So when the property changes, does it get rendered again or what? So let's see. So here, okay, this doesn't change. So filter text changes. Is there anything that happens based on filter text in product table? This is product. Okay, this is product table. Product table is saying, okay, so product table is saying, so whenever it gets rendered, is render called each and every time someone changes that or what? Okay, let's assume that render gets called. So when render gets called, if the property changes, if render gets called, then let's see if there is something else happening in the, okay, we set state. Okay, this gets re-rendered, huh? Okay, okay. Because we are setting state, actually this gets re-rendered. So when it gets re-rendered, basically this products, filter text, all of them go. And then inside product table, the render method gets called. The render method is going to do a lot of processing. So it'll say for each of the products, okay. So if filter is blank, then we return. Is that what it is for each product? Okay. So if nothing is found, basically we'll just return empty product table. Product category is not equals to the last category. Rows push. Product category row. Category is this. Okay. Okay. This gets built. Understood. Basically, it gets re-rendered and then not last category. Where does it use? Where is it using the filter text? Okay. Oh, if it is not found, then he skips that. Return. Product name dot index of filter text. Or if it is not stored, and stock only. Anyway, let me push a bunch of product rows with the product and the product name. And then this gets rendered. Okay. Perfecto. Done with the first section of quick start. Now the next section is advanced guides. We'll tackle that tomorrow or a little later in the afternoon. Thanks whoever is watching. Anyway, so this is the quick start for React. I think it's just going through the React guide. So at a later time, we'll start coding something. Thank you guys. Later.